Hi guys, welcome to a new video on differentiation under math studies. In this video, we shall focus on questions that involve local minimum points and local maximum points. These are points on the curve where the slope is 0 and hence f dash of x equals 0. In this video, we shall tackle these 5 questions, and I shall begin question 1 shortly. So the first question that we shall tackle came in paper 1, November 2007, question 15. Kindly take a minute and pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, you are given the function f of x equals ax squared plus 4 over x minus 3, and you are required to find f dash of x. We have encountered similar problems before. However, maybe the new feature here is that the coefficient of x squared is not a number, it's a constant, it's a, but it is dealt with the same way as any number would be dealt with. So you can just assume this a is a 5, for example. The same rules apply exactly. So let's attempt to differentiate this. But first, as we did before differentiating, before finding f dash, I'm going to change one term in f of x to make it easier to differentiate. And that is the term that has x in the denominator. So instead of 4 over x, I'm going to rewrite this as 4x to the power of negative 1, and then I shall attempt to differentiate. So the first term in the green equation is ax squared. I shall multiply the old power by the number next to the variable. So I'm going to get 2 times a, which is 2a, and x squared becomes x because the power is decreased by 1. For the second term, negative 1, which is the old power, multiplies the 4, which is the number next to the variable. Hence, we get a negative 4. And the variable is reduced in power by 1. So x power negative 1 becomes x power negative 2. A nicer way to write this red expression is in the form of the blue expression right there, where I returned the x power negative 2 back to the denominator as x squared. However, you do not really have to do this to get the marks for question A. Sometimes this helps you solve maybe question B and so on. So it's a nice technique to know. Anyway, for question B, we are told that the function f of x has a local maximum at the point where x equals negative 1. So we should infer from this that since there is a local maximum, as the title suggests, f dash of x equals 0. However, f dash of x equals 0 at a particular point, which is the point where x equals negative 1. So instead of f dash of x, I'm going to write f dash of negative 1 equals 0. And f dash of negative 1 simply means the value of f dash of x when x equals negative 1. So I'm going to plug the negative 1 into the blue expression, hence obtaining this orange expression right there, 2a times negative 1 instead of the x, minus 4 over negative 1 squared instead of the x squared. I shall simplify and solve, getting negative 2a minus 4 equals 0, hence a equals negative 2. So take a minute to write this down if you will, and I shall begin question 2 shortly. So question 2 came in paper 1, November 2012, question 15. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So for question A, we are given the function f of x equals 5x cubed minus 4x squared plus x, and we are asked to find f dash, and this is very straightforward. You can look through previous videos if you have trouble understanding how we obtained the red equation. As for question B, which is the purpose of this video, we are required to find the x-coordinates of the local maximum point and the local minimum point. So what we already discussed concerning maximum and minimum points is that f dash of x equals to 0 in both. Hence, we need to solve the equation f dash of x equals 0, which translates into 15x squared minus 8x plus 1 equals 0. And we solve this using the GDC as follows. So I've written down the dark blue equation, 15x squared minus 8x plus 1. And I need to find the zeros of this equation. So I shall click on trace, getting this curve. I'm going to click on second, calc, 0. And I can see that there are two closely spaced points, so I need to watch out. So the first point is roughly somewhere here. So I need to find the left bound, which is right there, and the right bound, which is maybe somewhere here, and then guess that the 0 is roughly somewhere here. And the calculator tells me that there is a 0 at x equals 0.2 or 1 over 5, which is the fraction form of 0.2. I will repeat the process for the second 0 now. So again, calculate 0. And now I need to find the second x-intercept. So the point I'm looking for is roughly somewhere here. So the left bound will be somewhere to the left. The right bound shall be somewhere to the right. And the point I want is roughly around here. And the calculator tells me that x equals 0.33333, which I should know to be 1 over 3. Hence, the two values of x are 1 over 5 and 1 over 3, which I have written down right there. Now, what is new about this question is that I need to distinguish between the local maximum and the local minimum. I need to find which of these x values corresponds to the local maximum and which of these corresponds to the local minimum. So what you need to know is that in both cases of maximum and minimum, f dash of x equals 0. However, what sets them apart is that for the maximum, f double dash of x is less than 0, and for the minimum, f double dash of x is greater than 0. F double dash of x is basically the derivative of the derivative, which is obtained by differentiating the red expression right there to obtain this dark blue expression. Again, this is simple differentiation. So in order to remember which one is which one, you can remember this by the fact that the local maximum kind of looks like a frowning face. If you can see, this part of the graph right there is more of a frown. Hence, a local maximum is always negative in f double dash, whereas the minimum is kind of a smiling face. Hence, the f double dash value of a minimum point shall always be positive because it's a smiling face. And again, there is another local maximum here, and you can tell again that this is also a part of a frowning face. So always remember that the local maximum has a negative f double dash value, whereas the local minimum has a positive f double dash value. So what do I mean by that? I mean that I shall plug in 1 over 5 and 1 over 3 into the expression of f double dash of x. So I'm going to test f double dash of 1 over 3 and f double dash of 1 over 5. So f double dash of 1 over 3 was evaluated to give me 2. Again, I just plugged 1 over 3 into this equation right there. And I got a positive value. Hence, 1 over 3 is the x-coordinate of the minimum point, whereas 1 over 5 gave me a negative value, hence this is the x-coordinate of the maximum point. So we conclude that the golden expression right there is actually the answer to BI. The value of the local maximum is x equals 1 over 5, and the value of the x-coordinate of the local minimum point is actually x equals 1 over 3. So this concludes our video. Take a minute to copy this down if you will, and I shall begin the next question shortly. So the third question that we shall tackle came in paper 1, May 2013, time zone 1, question 15. Kindly take a minute to try to answer this question, and the answer should follow through shortly. So we are given the function f of x equals ax cubed minus 3x plus 5. And in question A, we are required to find the derivative. So for ax cubed, the old power of x, which is 3, multiplies the number next to x, here represented by constant a. So we get 3a, and the power is reduced by 1, so we get 3ax squared. And obviously, negative 3x becomes negative 3, and the 5 vanishes. So in question B, we are required to find the value of f dash of 0. F dash of 0 is obtained by setting x to 0 in all of the equation, hence x squared here becomes 0 squared, or just 0. So 3a times 0 minus 3 equals 0 minus 3, which gives us negative 3. Now, in question C, we are told that the function has a local maximum at x equals negative 2. So at the local maximum, we know that f dash of x equals 0, and since x equals negative 2, hence f dash of negative 2 equals 0, and f dash of negative 2 is obtained by substituting x with negative 2 into the equation f dash of x, So 3a times negative 2 all squared minus 3 equals 0, and we are required to find a. So again, in order to find a, I shall simply equate f dash of negative 2 to 0, and I shall do so by replacing this x right there with a negative 2. So this is easily solved. 3a times negative 2 squared equals 3a times 4, which gives me 12a minus 3 equals 0. Hence a equals 3 over 12, or 1 over 4. So take a minute to write this down if you will, and I shall begin question 4 shortly. So question 4 came in paper 1, May 2014, time zone 1, question 15. Kindly take a minute, pause the video and attempt to solve, and the answer shall follow through shortly. So we are given y equals x cubed plus kx, and we are asked to write down dy by dx. So to differentiate x cubed plus kx, we simply get 3x squared plus k, where k is treated like any regular number. So assume this was 5x. The derivative of 5x is 5. Hence, the derivative of kx is also k, where k is a constant. So the curve, we are told, has a local minimum at the point where x equals 2. And again, we know that local minimum means that f dash of x equals 0 at x equals 2. So we are going to go to f dash or y dash and replace the x with the 2 and set it to 0. So that's what I did in the green equation right there. Instead of x, I wrote down 2, and I set the equation to 0. So 3 times 2 squared gives me 12. 12 plus k equals 0, hence k equals negative 12. Now in question C, I'm required to find the value of y at this local minimum. So we know that x equals 2 and we are required to find y. And we have obtained k as negative 12. So in this equation, I'm just going to replace x with 2 and k with negative 12. And this is what I did in the equation in gold right there. So 2 to the power of 3 instead of x plus k, which is negative 12, times 2 instead of x, gives me 8 minus 24, which is negative 16. So take a minute to write this down, if you will, and I shall begin the fifth and final question shortly. So question 5 came in paper 1, November 2013. Question number 9. Take a minute and attempt to solve, and the answer shall follow through shortly. So I am asked in question A to expand the expression x times 2x cubed minus 1. And this is simple algebra. I get 2x to the power of 4 minus x. Now in question B, I'm required to differentiate f of x equals x times 2x cubed minus 1. I cannot do so unless I use the expanded form. So instead of writing f of x down as x times 2x cubed minus 1, I've chosen to write it down as 2x power 4 minus x. This shall help me differentiate. So the derivative of this black expression is 8x cubed minus 1, and this is pretty straightforward. Now moving on to question C, I am asked to find the x coordinate of the local minimum of the curve y equals f of x. So basically I need to set f dash of x to 0 as we've done before and find x. So 8x cubed minus 1 equals 0, and I solve this either algebraically or using the GDC. This is up to you. So I've chosen to do it algebraically here for a change. Now 8x cubed equals 1. I took the 1 to the other side. I divided both sides by 8. So x cubed equals 1 over 8. And I obtained the cubic root of 1 over 8, which shall give me half. And this concludes our fifth and final question. I hope you have found this video useful. You can pause to write this down, and see you in the following video.